Good evening and welcome. Thank you for joining us. Welcome. So, the best thing we're going to do so that we have a very good evening together is to make sure to share the link right now. This particular link, you see that arrow button, that's the share button, and then post it on your status, post it on group chats. Allow people to join you to come and learn because I'm going to be dealing with waves tonight. So, you need to invite your friends to come learn. You can post it on your statuses, your group chats, and also your Facebook page and everywhere you know that students are preparing for exams. They really, really need to participate in tonight's class. And I'll be starting in 2 minutes' time. So let's take this minute to start sharing the live stream. Told you guys 9 p.m. I will start. I keep to time a lot. So 9 p.m. we are starting. So let's use this time to share. Thank you for joining us. You're welcome. Good evening to you. Good evening. Good evening. Say that's the man. Yeah, that's the man, of course. Thank you for joining us today. So please keep sharing on all groups. Keep sharing and keep hitting the like button. Please make sure this particular live is engaging. Always be on the comment section to have a conversation so that and the conversation should be about what we are doing exactly. So have you done that? If you're done sharing, just come back and say done. Let's start. Remember the time is just here. If you're done sharing, come back and say done. So let's start off the class immediately. If you're done sharing the live stream, come back and say you're done. Just say done, then we're gonna start right away. So tonight I'm gonna be focusing on vibrations in string. So there are a lot of parts of waves as you're gonna be coming to live stream today's week regularly. We're going to be touching light waves and sound waves, other parts. So in this tutorial, we're going to be looking at vibration in strings. So if you're ready, let me know. Tell me you're ready. So let's start. If you're ready, tell me that you're ready. So let's start. I need to see you speaking in the comment section that you are ready. So let's start because I'm ready. All right, I can see that you all are ready. So remember, I'm going to be going straight to the point, direct to what you need, and no much stories, straight to the point. But I want to build understanding. Even while I'm doing that, I'll be building understanding. So now, when we talk about vibration in strings, when a stretch string fixed at a like this, is what I'm saying. When I have a stretch string, like they are fixed at this end. This is one end. Some people may just want to style this particular end like this, style this particular end like this. It's not really a problem. Okay. So we're just trying to say that these are ends. All right. So when a stretch string fixed at both ends, gently plucked, if this is a string that is fixed at this both end, if this is a string, and it is gently plugged. Immediately it is plugged at the middle here, maybe somewhere at the middle here, the string is plugged, just like your bass guitar. When you plug the string at the middle here, what happened? There is what we call transverse stationary waves. So that transverse stationary wave is going to look like this. So that's where you have this first setup. This particular first setup, probably you must have seen it in your book before. I don't know how to sketch so much, but then let me manage to see what I can do. We're going to be doing so many things from this particular tutorials. So that's how we got this first setup. When this is plucked from the middle gently, Then we have this first setup. That means from this point down to this point, we have what we call the length. And the length has a formula which is lambda over 2. You can see I'm going straight to the point. Immediately I've given you a formula for this first setup. This particular one is what we call the simplest mode. Please put it down. It's called the simplest mode. The simplest mode, the simplest mode of vibration of this particular wire, as like you're seeing like this. So that's why I told you that the distance between this particular one is talking about the distance. I'm going straight to the point that will help you pass your exam. We do not have time to do a lot of things, but we're going to do calculation. The distance between these fixed ends is equal half a wavelength. Is equals half a wavelength. What do we mean by half a wavelength? Some people don't understand it with grammar like that, but if you want to show it by formula, it is L equal to, L is standing for the distance, equal to half. Half a wavelength is half a wavelength like this, and this thing is the same thing as saying L equal to 1 times lambda is lambda over 2. Does that make sense? Is it clear? Does that make sense? Hey guys, talk to me, please. Let's be lively. Let's be lively. Does this make sense? Let's be lively, please. So we move forward. Does it make sense? Talk to me in the comment section. So I need you to know that this particular L, the L is representing distance between the fixed end, and then this lambda you're seeing here, this lambda is just talking about the wavelength. And remember, the wavelength is always in meters. Okay. Now, there's another key important stuff. If we have this particular formula like this, if we agree that L is equal to lambda over 2. Guys, if we make this lambda the subject of the formula, what will be the answer? If we make this lambda the subject of the formula, if we make lambda the subject of the formula, make lambda the subject of the formula, tell me in the comment section. Everybody should know that's the importance of mathematics. You see why math is necessary. Make lambda the subject of the formula. What would you have? Please show me your good. Show me your good. Show me your good, guys. Show me your good. Yes, somebody just got it correctly. It will mean that by the time you cross multiply 2 times lambda, 2 times L, you're going to be having lambda left alone. Lambda will be equal to 2 times L, which was 2L. Good. Congratulations to you guys. You guys are good. You guys are good. If you're not able to understand as at when I asked, at least by now you should understand this particular stuff. But remember, you were also told, please take this as equation 1. Let's use this as equation 1, and this is equation 2. Okay, let's move forward. Please, here, if you want to screenshot, a screenshot that is allowed. If you want to copy, we may not have time to wait for you. So the best thing I would recommend you should do is to always screenshot after I'm done. If you know that the paper is about filling up, screenshot if you need the information in your notes. That is the best thing I recommend you should do. Is that okay? Can I move forward? Please answer me because I want everybody to be carried along. Can I move forward? Let me know. Okay, somebody said yes, sir. Okay, let's move forward. Now, in case of those who are coming, we are talking about waves. And the part we're talking about is vibrations in string. Okay, I was going to say that if you remember that wave formula, a lot of you are familiar with, some of you, not even everybody. V speed equal to F times lambda. How many of you are used to this one? So many of you know about this particular one. So in this case, I want to make this F the subject of the formula, this frequency. Please, this particular is for speed. This one is for, you can call it speed or velocity if you want to. You can call this one frequency, and this is what we call the wavelength, lambda. So if I decide to make the frequency the subject of formula, what would that be? Let me see that in the comment section. Everybody make frequency the subject of formula. Let's be fast about it. We don't have so much time. And we all make frequency the subject of formula. What do we have? I want everyone to be carried along. If we make, let's say this one is equation 3. So if we make frequency the subject of the formula, it means that we are literally going to divide both sides by lambda. We're going to divide both sides by lambda, divide both sides by lambda, and see that this and this will cancel. That means we will have the frequency to be equal to V over lambda. Let's say this is equation 4. Please, all this equation 1, equation 2, equation 3, equation 4 is not really necessary. In case if I want to make reference, that's why I'm just numbering this equation. So I'll say, remember what we have in equation 2. It makes you understand, oh, yeah, this particular equation. That's why I'm numbering it. It's not really necessary. But make sure you store this formula in your formula bank because you need it in your exams. Store all these formulas I'm producing in your formula bank. You will need it in your exams. Now, I want to connect something. Remember equation, I want to connect two equations together. Remember when I said that lambda, I don't know how many of you remember, recall, let me use recall. Recall when I said lambda is equal to 2L, we derived it. Do you remember this particular formula? Check your note. If you don't remember it, check your note. Do you remember this formula? If you don't, please check your note. Please check your note. If you don't, please check your note. Oh my God, let's be fast about that. Check your note if you don't, please. Do you remember that formula? I want to connect this. This was equation. If you check your equation 2, that was equation 2. Now I want to put this equation 2 into equation 4. What do I mean? Anywhere that you see this particular lambda, replace it with 2L. So I will have F equal to V divided by, in place of this particular lambda, see lambda is 2L, I'll just replace it with 2L. I have formed a very unique formula. Let's say this is equation 5. Pay attention to that particular formula. I want to give you the name of this formula, this equation 5. I want to give you the unique name for it. Are you catching along? Are you following? Good. Somebody said yes. Now, this particular frequency has a name. So we're not going to leave this frequency like this. It has a name. Let me connect you. Let me show you something. If you remember that in this, I told you that this is the simplest mode of vibration. So in this particular simplest mode of vibration, it has a name for the frequency. Let me put it in a statement. In this simplest, let me put it in statement form, mode of vibration, the frequency has a unique name. Frequency is actually called the fundamental. Let me use red. Fundamental frequency. So this fundamental frequency we use F naught. That means I'll go over to this particular formula and change that F to F naught. That's the unique name given to it, fundamental frequency. And finally, you should also note that the vibration and the vibration is called, thank you guys for your support. All of you that are hitting the like button and sharing the live, thank you so much. You are my great supporter. Thank you for the encouragement. Others, if you're not supporting, if you've not hit the subscribe button. That will help you. That subscribe button, you need to hit it right now so that whenever I come up live again, you receive notification. If I post video, you receive notification. So, and the vibration is called the fundamental mode of vibration. Now, these things are going to be useful. All these things I'm telling you, they're going to be useful in your theories. Remember, it's not only calculation that comes in your exams. You also need to understand the theories. That's why I'm taking my time. So look at the unique equation I want you to store. F naught, this F now is now going to be written as F naught equal to V over 2L. Remember this formula? I told you the name of this formula is the fundamental. Fundamental. I'll keep repeating it until it clicks. Fundamental frequency. Fundamental frequency. Or some textbook, instead of calling it fundamental frequency, they will call it first harmonic. First, first harmonic. First harmonic. For some of you who were with me on TikTok a few minutes ago, remember when I mentioned first three harmonics? First three harmonics. So you can see where that stuff came up. Somebody say he has been following me since 2022. That is serious. That is a long time. Eddie, thank you so much. And I feel maybe it should be the other account. That's awesome. So now these things I have just done right now, please digest it. I'm taking my time to do this thing, guys, so that you do not have problem with these particular problems anymore. So what next are we supposed to do? I want to go over to the next thing, but please let me know you're done so that we continue. Okay, so you probably must have been hearing, remember I said it's first harmonic. You probably must have been hearing about overtone, overtone. At what point should we have overtone? Now, this is simple. Any resonant frequency above the fundamental frequency, anyone you have above this fundamental frequency is what we call the overtones. Remember, I said any resonant frequency above this fundamental frequency are what we receive. Should I write it down? Are what we call the overtones. That's the point overtones comes in. That means if I have any resonant frequency that is above this, I will just refer that to be my first overtone. But at this point, there's no overtone here. We just have first harmony. Does that make sense? Is that clear? That means it is possible for us to have higher fundamental frequency. It is possible for us to have higher harmonics, like higher frequencies. It is possible for us to have that. How do I achieve that? It means that we can obtain that by doing just small stuff right now. Let me show you that. Let me know if you're getting what I'm saying.